Alrighty, today's lab is brought to you from the fancy eating room. Your lab this week is all about torque and center of mass and balancing things. So if you've watched the PowerPoint, the video, you found out a little bit about how to balance some things. And one way to balance some things is you have to do it around the center of mass of something. And so this is an apparatus that's relatively easy to balance because the center of mass is below the balance point. It shifts around. To find the exact center of mass, all I have to do is balance it in 3 dimensions. I can find the exact center of mass of this thing. It doesn't have to be within the object. So for a lab, I don't know what kind of materials you have at your house, but I suspect you use some tree somewhere, so there's some sticks. You might have a shoe, and you might have a can of pop or something, and something you could hang that from. So the first thing that I did is I found the balance point on a stick. Now it actually may be easier to do with a bent stick because right now the center of mass is right at this point right over here where it's balancing. And because it's bent, it actually causes the center of mass to drop a little bit, making it much easier to balance. This thing, if I tried to balance it in the other direction, it's almost impossible because the center of mass is above where I'm trying to balance here. So as long as we drop the center of mass below a balance point, like this point we're going to call fulcrum, it's a lot easier to balance things. So the center of mass, the stick is right there, and what that means is all of the mass, we can consider all the mass to be right there. Center of mass, center of gravity, relative produce the same thing. Center of gravity, center of mass, doesn't matter which one. So your task, should you choose to accept it, is to find an unknown mass. I've got no idea what the mass of this shoe is. I have a relatively decent idea what the mass of this can full of sparkling watermelon water that tastes like cancer, what that would be. And the reason is because it's water. And it's 12 fluid ounces, which is 355 milliliters. Well, if that's 355 milliliters of water, that means there's 355 grams in this thing, so I know what the mass of this thing is. Except the can is about 12 grams. I happen to have a handy dandy measuring tool in the kitchen there that actually measures in grams, ounces, and whatever. So I found the cans to be about 12. So if you don't have one of those, all you have to do is find out, well, how much liquid water do you have in there? And whatever many milliliters of water have, 1 gram of water takes up 1 milliliter of volume. So it's a pretty easy way to find the mass. So in reality, I know this is 367. So what you're going to do is, so I know what this is. I really don't know what this is until I put it on the scale in the kitchen, but I get in trouble if I put dirty shoes on top of the thing to put food on. So to find what the mass of this is, as soon as I put a weight on one side, that's going to make what's called an unbalanced torque. Because now I have a force acting not on the center mass. If I put it in the center mass, there's no torque whatsoever. There's no twisting going on. But if I put it off the center mass, it creates a torque. If I put it close, it's a little torque. If I put it out here, it's a lot of torque. Because torque, if you remember from the video, is 2 things. One is the weight or force of this thing and where does it act. The shoe, I can feel. It's a little bit less massive. So think to yourself, which one's going to be closer to there to balance? So here's your task for your lab, if you choose to do it, is to find the mass of an unknown. This is my known that I'm putting on here, by the way. So I'm putting on a known mass of 367, because that's the 355, plus my 12 grams, which is my aluminum can. You can use the thing of milk if you want to. Maybe you have a big stick at home. I don't know what you got at home. But you need something that's a known mass is the key. Here's my unknown mass of my shoe. I'll try to keep it from rubbing up against the post there. But at some point, I'm going to find a balance point. Because it drops the center of mass between here, so it's relatively easy to balance things once you drop the center of mass. So, I actually have no torque here. I have what's called this direction would be going backwards to the clock. That'd be a counterclockwise torque, balancing with a clockwise torque. But the torque here is the same as the torque here. Why is this one further out, you might ask? Well, as you might have guessed, it's less massive. But I can solve for that unknown with a measurement tool. I don't have a lot of fancy measurement tools at home, but I found this paper that has lines on it. Since these lines are all the same spacing, I can use these lines to tell what my distance is. I can count the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and a third. It's 15 and a third lines between here and here. So now I just need to find the number of lines between my center of mass, coming up my ugly face, and the fulcrum here. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 23.0. It landed right on the strings right there. So knowing my lever distance times my unknown mass, and I know this is the 23, this is what I said it was a moment ago, times that mass, I just solved for my unknown. This is less massive than that. For full credit, do a second measurement of something more massive than this. So for your lab, for 2 bonus points, you're going to show me the work to find the mass of your unknown of 2 things. One less massive than your known, and one more massive. All right? Have a good one.